Hi everyone, hope you're well and not too bored. So 8D, the nth term for a sequence. And it's either going to be modeling growth going up or decay going down. So nth term just means something could be the 6th term, the 7th term, the 10th term, the 20th term. So we'll do some work and the question might be, what will be the value of the 7th term, for instance, something like that. So we can calculate the term at any time. So like I said, we could find the 2nd term, the 3rd term, the 20th term. And you've got a starting term, and then we've got all the other terms. So we've got the 1st term, 2nd term, 3rd term, 4th term. That's what all this means. So here's what we've seen before, the initial value here, and then we've got the next term, it's the previous term, plus a constant. So if we're generating the nth term, when we have linear growth, we have a plus. When we have decay, we have a minus. And here it's just n times d. So n would be like the 5th term. So it'd be the 5th term times by whatever the growth is. And here it'd be the term times the growth, but this time we would take it away. Growth plus, decay take away. So let's have a look at some notation. So here's what we just looked at before. If we got an increase, so simple interest, that would be an increment, wouldn't it? That'd be going up. So there's the formula from the previous slide, and D is as it was from the previous one. So it's just the interest rate divided by 100 times by our initial value. So this formula here is the same as this formula here. So these two formulas are the same. Here they put D, and don't forget that R over 100 times D0 is D, isn't it? So it's just adding it in that way. So making the formula a little bit more complicated. It means we can just use one formula. We don't have to use D and then work out what D is. So this is depreciation. So plus, minus. That's the same. That's the same. That's a plus. That's a minus. And again, this bit here is just D, isn't it? And if we're here is when we're decreasing it by a percentage. Here it's when we're decreasing it by a set amount, like the lawnmower example. You know, it was $3.50 for every time you did the lawn. It just depreciated by $3.50 each time. Linear growth, linear decay. That one's linear decay as well. Okay, let's have a look at an example. So simple interest, starting off with $3,000, and looks like we add $260 each year. So 4 questions. Let's go through this. So what is the principal of the investment? How much is added to the investment each year? So really there's no mathematics work to do. Read it directly from the recurrence relation. So initial amount, principal 3,000, adding each year $260. So that's just straight 3,000, 260. B, write down the rule for the value of the investment after n years. So I'm going to substitute into the general rule. So remember it was Vn equals V0 plus Nd. It's plus because it's going up because it's interest. So Vn equals V0, 3,000, plus N times D. And our D was 260. So we just do a little bit of writing it like grown-up maths. So we know that N times 260 we would write as 260N. So Vn is 3,000 plus 260N. Use the rule to find the investment after 15 years. So here we just sub N equals 15 into the rule. So 3,000 plus 260 times 15, $6,900. Use the rule to find when the value of the investment first exceeds $10,000. So Vn is 10,000. So we do 10,000. And I recommend that we just use solve here. So from straight here, just go straight to your calculator, do solve, and it will give you the answer 26.92. So we'll first exceed 10,000 after 27 years, because after 26 years, it won't have gone over 10,000, will it? So make sure, as we've done here, you write down the answer that your calculator gives, and then you explain your answer here. Okay, so if you mess up here, you get most of the marks because they can see what you've done on your calculator. Amy invests $3,000 in a simple interest, paying interest at 6.5% per year. So in the previous example, they told us what the interest is. Here we're going to have to work out what the interest is. Use the rule to find the value of the investment after 10 years. So here's the formula, V0. That's what our D is, isn't it? Here's D. So we're going to work out what the interest rate is. As we know what the interest rate is, we're going to work out how much it all is. So V 3,000, number of years, here's our interest rate, there's our principal, 44950. So we're just going to go straight into that formula. So we're allowed to take our books in with us, we're allowed to take all our notes in with us to test and exams. As long as we've got the formula, we're okay. The trick is knowing which formula to use. All right, set of office furniture. Very nice office having furniture like that, yes. So depreciation. So if we buy for the school some furniture, some chairs, lovely chairs and tables. If you imagine the classroom, lovely chairs, lovely tables, very expensive. They'll cost a certain amount, but over a number of years, they'll be worthless, and they'll just chuck them away probably, or they'll maybe do them up. What is the initial value of the furniture? By how much does the furniture decrease in value each year? So again, that's just straight from the question. Straight from the question. 12,000, 1,200. Write the rule for the value of the investment after n years. So this is where we're going to have the n times d one, yeah? So we've got the Vn V0 minus nd. So 12,000 minus n times 1,200. And we would write that as 1,200n, yeah? So there's the answer to that one. C, use the rule to find the value of the investment after 6 years. We're just going to sub in 6 for 6 years, 4,800. How long does it take for the furniture's value to decrease to 0? So here, 0 equals 1,200 minus n times 1,200. So we're just using this formula here. Again, go straight to our calculator and do a solve. Ends up being 10 years. Photocopy in the office costs $6,000 when new. Its value depreciates at a flat rate of 17.5%. What is its value after 4 years? So 6,000, 4 years, 17.5%, cost 6,000. So that's 20 your calculator, $1,800. That's just the same as that question on the previous slide. Yeah, we just go straight into that big formula. Hairdryer in a salon was purchased for $850. $850 for that lovely, lovely, lovely hairdryer. Depreciates by 25 cents for every hour it is in use. Don't forget 25 cents, $0.25. Write down the rule. Find the value of the hairdryer after 50 hours of use. On average, the salon would use the hairdryer for 17 hours each week. Doesn't seem like much to me. How many weeks would it take for the hairdryer to half? Okay, use the general rule. So we know that initial was purchased for $850 and it depreciates by 25 cents for every hour it is in use. So Vn equals 850 minus 0.25n. 50 hours of use, substitute n equal to 50, ends up being $837.50. So again, with our calculator, not too tricky. How many weeks will it take for the hairdryer's value to half? So we have to half the value of the hairdryer, solve it for n, and then divide by 17 to get the number of weeks. So half of 850, 425. So we have 425. So using this value here, it's Vn, 425 equals 850 minus 0.25n. So use Solver on our calculator for this. Ends up being 1,700. So it's 1,700 hours. So divide by 17 because it uses 17 hours each week. Ends up being 100 weeks. Using our calculator for that one, as I mentioned. So roughly about 2 years. Yeah, 100 weeks is back 2 years. So after 2 years, it's halved in value. So a little bit of a table again. So simple interest, things going up, decay, we've got the flat rate and the unit cost one. So this is where we have to work out what the depreciation is from the interest rate. And that's the big formula where we just, instead of having that is D, isn't it? So we just put that into D. So that's D, so it's still Vn equals V0 plus N times D. Sometimes that formula is really good because we can go straight to it. Depreciation one, so it's where it's going down, use the same formula, going down. And unit cost is where it's going down by a certain amount. We don't have to work out what the actual amount is from a percentage. Got some videos for you to watch, one on simple interest, one on flat rate depreciation, one on forward and backwards. That's an interesting one. That's where you can use the solver on your calculator, and one on unit cost depreciation. It's 12 questions to do there, so it's starting to get a little bit more work for you to do. So make sure you get them all done. And in order to work those videos, obviously you've got to go to Google Classroom, open up the PowerPoint, find the right page where those 4 videos are, and watch the videos from there. Mr. Patch, over and out.